Okay, we are looking at page number 30, and this is going to be a video where I'm going to try my best to remember that I don't have my AirPods on. And when I don't have my AirPods on, the microphone is actually the iPad. And because of that, it picks up the sound of my pencil tapping when I'm writing. So I'm going to try to tap gently so that it's not insane and annoying. We are looking at solving systems of equations. So in the math world, a system is when you are solving more than one equation at the same time. And when that happens, there is one of three outcomes that you would have. So I'm going to show you this right here. I'm going down a little bit. When you have two lines and they intersect in one spot, which is right here, then that means there's one solution. That one solution happens right here, and the solution comes in the form of an ordered pair. And this happens probably 90% of the time. This is going to happen a majority of the time. Then we have the situation where we have two lines and they're both drawn together, and they never intersect. They're parallel lines. And so if they never intersect, then that is the situation where there's no solution, because the solution happens where lines intersect. Then we have the situation where you graph two lines and they are the same line. And that means that they infinitely intersect. And if they infinitely intersect, that means that there's infinite many solutions. So that's three things that can happen. We're going to look at a few different scenarios. I'm going to do my best to make this easy to understand, hopefully. So here we have a couple of different situations. The lines are already graphed for us. We just have to say whether or not there is none, one, or infinitely many solutions. And so I'm going to use my highlighter to draw out some of these questions. For instance, if I was looking at this line, which is negative x minus 3, that is this line right here. And I'm looking at this line, y equals x minus 1. That is this line right here. And these lines intersect only once, so we can go ahead and say that there is one solution. That's it. And actually, if we were being specific about the solution, it is the ordered pair negative 1 comma negative 2, but we're just going to look at identifying the lines. Number 2, here's a line. I'm just got to make sure I'm using my highlighter and not my pen. 2x plus 2y equals minus 6. So that line is right here. Notice that I'm coloring over that last one. And y equals negative x minus 3. Well, notice that that is this line also. It's just written in a different format. One is written in general form, one is in the form of a linear equation. They are the same line, and since they're the same line, we can go ahead and say that there is infinitely many solutions because they do nothing but intersect. So the intersection points are everywhere. Now I'm going to go ahead and I'm going to erase some of these if it lets me. It looks like it's not going to let me. I don't know, maybe it will. Not really. It's okay. Well, I'm not worried about it. I'm going to use green to highlight y equals negative x minus 3. And that's on there again. Now I'm using green for it. And 2x plus 2y equals 4. So I'm going to use this color. 2x plus 2y equals 4. That is right here. These two lines, as you can see, look like they are parallel and they look like they will never intersect. So there is no solution. Last one, let's use my highlighter that is, I'm going to use a blue highlighter, I guess. 2x plus 2y equals negative 6. Well, that's been highlighted a lot of times, but here's that one right here. And then 3x plus y equals 3. That is here. You can see these lines clearly intersect, so we can say that this is the situation where there's one solution. Let's go on to the next page where we are actually going to graph some lines and try to figure out what the solution is. And so, again, we've already graphed lines before. So I'm going to go ahead and do this one with you. Y equals negative 2x plus 1. Here is the y-intercept plus 1. Rising and running when it's a negative 2 for the slope. I can rise +2 and run -1, or I can rise -2 and run +1. This is the first line right here. In this, it's so funny because this iPad doesn't have the ability to do straight line, or this app doesn't have the ability. It's fine. This one, -1 is my y-intercept, rise 3, run 1. It's right here. And this is, and we have to look for where they intersect. And I think because of my straight lines, these actually intersect at 0.5, 0. So it looks like it's between 0 and 1, and the y coordinate is right on 0. So there is the answer to that one. Now, what if I'm not sure if that's the answer? You can always plug these into Desmos and hover on the intersection point, and it will give you a very what's the word I'm trying to say, accurate answer. This next one, I have, for my first one, -1 is my y-intercept, and my slope is -2, so I went down 2 over 1. I rised -2 and ran +1. And then this one here, +2, and then again, it's the same slope. And when it's the same slope, what you end up with is lines that are parallel, no solution, because they're parallel lines. I know my lines are terrible. They can't really hold a ruler on my iPad, so I'm just doing the best that I can. Just so you know, notice that same slope. They were parallel. The next one I have, my y-intercept is 0, and my slope is rise 1, run 2. So there we are. You can make as many points as possible to try to keep this accurate. The next one, my y-intercept is -1. My slope is -2/3. If I rise +2, I have to run -3, or if I rise -2, I have to run +3. Here is my drawing. Again, I'm looking for my intersection. These intersections are not beautiful, but I'm looking at potentially -1/2, -1/2, looks like. Okay, I'm going to give you a moment to pause the video and do 8, 9, and 10, and then I am going to reveal the answer, so go ahead and take some time to do that now. Taking a look at number 8, pretty straightforward, one answer, 1,4. Looking at number 9, we had parallel lines, so there was no solution. And then number 10, both of those lines are the exact same line, so they are right one on top of the other. If I was looking for a solution, that would be infinitely many solutions. So that's a thing with this one. There's another, let's see here. There's another practice thing on here. So what I'm going to do again is I'm going to have you do the pause. I'm going to reveal the answers. If you really want to do yourself a favor, you actually do the practice and then come back and check your answers with me and make sure that you've got this down pretty good. So I'm going to pause the video now. Hey, here is the practice example ones. Notice that the ones in blue are the same line. So y equals -x minus 1 was the same as 3x plus 3y equals -3. And then down below, I know actually they were asking for you to state how many solutions, but we can state what the solution is. So that's what I did for 4, 5, and 6 after graphing them. So hopefully you got something similar. Okay.